A quadrilateral has sides 5, 6, 7, and x, such that the side x is opposite the side of length 5. If x is an integer, how many values of can x take? Oh, does anybody have an answer? Okay, so it seems like someone answered D. Is there any other answers? Okay, then I'll present the solution. So, firstly, I, for um these types of geometry problems, you usually want to construct a diagram. So, since we know the side x is opposite the side of length 5, we must have something like um, this, wherein the side of length x is opposite the side of length 5. Now, sorry, when presented with a problem like this, where you want to find how many values can um a variable take, it's, you usually should think about the triangle inequality, because it's very common to appear, and also like it helps, it restricts the quantities of x. So firstly, what do we know from let's say this triangle? Let's call it ABCD actually, so that we don't get lost. What do we know from triangle ABC and ADC? Basically, in other words, how can we restrict x using the triangle inequality? Actually, I forgot to mention the triangle inequality is that for a triangle, for another triangle ABC, actually let's call it DA. Yeah. For another triangle DEF, when you have side lengths A, B, and C, it's that A plus B is greater than or equal to C. Actually, for a non-degenerate triangle, it's usually just A plus B is greater than C. B plus C greater than A, and A plus C greater than B. So how can we use this information to restrict the values that x can take? Find the possible values. Yeah, actually, you're right. We can find the possible values of each. So, and that in turn restricts x, which is CB, because we can use a triangle inequality to bound x. So in that case, um, we know that 11, which is 5 plus 6, in this case, is greater than AC. The reason why I didn't put the greater or equal than sign is because we know this triangle and this figure is a quadrilateral. And we usually don't like include degenerate quadrilaterals. I mean quadrilaterals with degenerate triangles because they don't look like quadrilaterals. So yeah. Anyways, for we also look at it's, it's we also look at triangle ACD wherein we know that 7 plus x is greater than AC. Now this doesn't look like much information, but remember, ABC and ACD aren't the only triangles. We also have ABD, and BCD in order to apply the triangle inequality. So in this case, we must have five. We must have 5 plus 7 is greater than BD, is and also BC plus CD, which is 6 plus X, is also greater than BD. So um now that we have all this information, how can we use it? Well, yeah. I mean, elimination could work, but I don't think it really does work because there's inequalities all around. So it kind of makes things a bit messy. I think we should go back to Cobalt's suggestion here. Find the possible values of AC. Miss Sim, since we know that AC is less than since we know that AC is less than 11, um, we have a finite number of values of AC we can test. So let's just look at all these values of AC. Firstly, we can't have AC equals 0, of course, because we don't want the degenerate triangle in there. So let's look at AC equals 1. We don't want to do 11 cases. I'm just going to try to show how we can approach this more systematically. If AC is equal to 1, then 7 plus x is greater than 1. So x is greater than -6. That doesn't tell us a lot, but it also shows like, oh, if AC um if AC is um less than or equal to 7, then we basically just know that x must be positive. I must be just only needs to be positive. It can be take on values from 1 or greater. Anyways, so since it doesn't imply any more restrictions on x, um, we have to look at BD instead. So in this equation here, because this equation doesn't tell us that much yet, um, we know that 6 plus x is greater than BD, right? So thus, um, we must have um. Oh yeah, sorry. I also forgot to mention. We also know that Oh wait, yeah. Um, the sum of these three legs must be greater than or equal to x, because if you can think about it like you want to stretch the three legs as much as possible. And so to stretch them the most means to just put them all in a straight line, which is just adding them up. So we also have what 18 um it's less is greater than x. Anyways, besides that, just from seeing this, we just from seeing this, we have um this doesn't actually need to tell us this. I'm sorry. This only this equation only tells us that BD is greater than BD is less than 12, right? But this also means that if BD is less than if BD is less than or equal to 6, then we again can let x equal anything. And actually, with these two conditions alone, AC is equal to 1 and BD is greater than equal to 6. Actually, not even AC is equal to 1, but let's just put this and let's put AC BD is equal to 6 or something. We can um we realize that this doesn't put any more restrictions on x. X can just continue to be a positive. It can be any positive integer between 1 and 17. And so how much? And so x can just take any positive integer from 1 to 17, which means the answer is 17. Sorry, but yeah.